Hey guys, this is Ms. Mo. This is 11.3. 11.3 isn't that bad except for this one problem that's like A through F, so we're going to go through that sucker together, and then after that there's little baby problems that we'll do. Okay, so first we got to figure out what some words are. Okay, first, all the angles inside a triangle add up to 180 degrees. So all three angles add up to 180. We probably knew that. Okay, if you have a tiny little box in your triangle in a corner, that means 90 degrees. So this top triangle has a 90 degree angle at the top. Or this bottom left triangle has a 90 degree angle at the bottom left. Or this bottom right triangle has a 90 degree angle at the bottom right. Okay. Supplementary angles add up to 180 degrees, and I like to think of them as making a horizon. Okay, so if you look at these two angles, one says 60 and one says 20, and if you add those up, hot dog, you get 180. And the way I think of a sunrise is because it's kind of like it's like a horizon, like a sun. Woo. Yeah, no, okay, you don't have to think that. Okay, then if you look at this other sucker, this 50 plus this 130 on the outside, both of those make 180 when you add them up. Okay, so supplementary angles. It's two angles that add up to 180. And sometimes they can be on the same baseline, or they might not be on the same baseline, but they just have to add up to 180. So like maybe 11 and 169. Those are supplementary angles. 11 degrees and 169 degrees because they add up to 180. Okay, vertical angles are equal and they make an X. And another word for equal in geometry is congruent. So if you look at this X right here, yeah, the top and the bottom, those are vertical angles. So if I just gave you the top angle, 135, and I said, hey, what's this guy below? You could say, oh, okay, it makes an X. Yeah, okay. So that two sides of the X are the same degree. Yeah. And then this 45 and 45 are also vertical angles. So anytime you have maybe we have it going sideways like that. Here's a better one. Here's a sideways looking X. And those angles would be equal to each other, just like they were on this picture. And then these big fat angles, those would be equal to each other. Okay, so anyway, angles that are kind of across from each other in the letter X are equal. Okay, complementary means they add up to 90 degrees and they make a right angle. Okay, so as you can see, this 30 plus 60 equals 90. Or over here, 59 plus 31 equals 90. Yeah, okay. Adjacent angles have a common side and common vertex. That means starting spot. So, if you look at this picture, this top angle and this bottom angle, they are called adjacent angles because they start at the exact same spot at the vertex and they have this common side, like they both share the same side. Whereas if you look at this picture over here on the left, if you look at the 40, yeah, there's 40, the 40 angle. And then if you look at the 50, yeah, there's the 50 angle. And they share the same vertex or the same starting point because both of these angles start at this O'Reilly's, but they don't have a common side because look at the side of the 40. It's either this A or this B side. Okay, look at the side of this 50. It's either this C or this whatever that is side. Either way, they do not share the same vertex. I mean, they do not share the same side. So this example with the turquoise and the purple is an example of not adjacent angles. So these are not adjacent angles because they don't butt up to one another with the same side. Okay, let's look at this sucker. Alternate interior angles are equal. So alternate exterior angles are equal. Okay, interior angles are the angles on the inside. Yeah, okay. So this angle that's blue, that's the exterior because it's on the outside. And this other blue angle at the top, it's the exterior because it's on the outside. But interior would be any of these four, yeah, any of those suckers. And these two suckers are equal as long as you have two parallel lines with a line cutting through it. So, alternate interior angles are equal as long as this side to side and this side to side are parallel. Yeah. Okay, then we have something called alternate interior angles. Yeah. And if I was just talking about interior angles, I'd be talking about these four that I kind of pointed out. But when we say alternate interior, that means they're not on the same side. So it's not this 67 and this guy. This is not an alternate interior angle because it's on the same side of the line. But this other 67 degrees is alternate because it's on the alternate side of the line or the opposite side of the line. Another word for alternate interior is opposite interior. So, okay, and those are equal to each other. And I call it the Z property. It helps me remember. Like, if you think about the letter Z, here we go. Here's the letter Z. And in the letter Z, the acute angles formed by the letter Z are equal. So here's my letter Z. It's kind of stretched out a little bit, but that interior angle created by the Z's are equal. Okay. Then we have something called corresponding angles. Corresponding means they're on the same side of the line. So this opposite interior angle, see how the line is this crooked diagonal one? Yeah. And the two angles are on opposite sides? Yeah. Okay. And then if you look at this alternate exterior, and you look at that up and down line, the angles they gave us are, here, let me maybe use this, on the opposite sides of the line. One's on the left, one's on the right. They're on the opposite side of that line that cuts through our parallel lines. Okay, so corresponding angles are on the same side of the line. It only works if we have parallel lines. And I call this the F property because if you draw an F, or even if it's kind of crooked, it means the inside angles of that F are equal. Or if you follow that line that cuts through the parallels, those angles on that line are the same. Yeah. So if we look at this left-hand picture, it doesn't quite look like it, but if I kind of turn it backwards like this, it looks like oh look, it's the letter F. It's totally bass-ackwards, but it's still an F, okay? And those two inside angles are equal. Or if you look at this other example with the yellow, if I trace that, again, it's kind of a awkward looking F, but good enough. The inside angles of that F are equal. So that's called the corresponding angles. Okay, let's get started on that big old homework example. Ooh, yeah. Okay, and what we're going to do is we're going to go through every answer choice and say why it's wrong, and then we'll pick the correct answer. Okay, so we were given 6 pictures, and then the directions were to tell whether they're parallel lines, parallel lines, parallel lines. Well, they're only parallel lines if their vertical angles are equal, or their alternate exterior angles are equal, or their opposite interior angles are equal, or their corresponding angles are equal. Okay, so we're going to go through and check all this mess for each picture, but we're not actually going to check all of them. We're just going to check the answer choices. Okay, so this first sucker says, are M and N parallel lines? So here's my one line, here's my other, and it's asking if they look parallel, if they are parallel. Well, they look parallel, but looking has nothing to do with it. We got to prove it using fancy words and numbers. Okay, let's look at this. Part A says yes, because vertical angles are not congruent. Well, if we look at our definition, it says vertical angles are congruent. They are equal. They're called congruent. So this answer choice is automatically out because vertical angles are congruent. So that's just a bad statement overall. Okay, let's look at this next one. It says adjacent angles are 61 degrees each. I think I can zoom in. Okay, let's look at what adjacent angles are. Adjacent are right here. Yeah. Angles that share a common side. Okay, so this says adjacent angles are 61 degrees each. Okay, that means that if I have, part B, means that if I have two angles that share a starting point and a common side, this part B is saying that each angle should be 61 degrees. But let's check this, okay? Let's see if that's right. If I look right there, yeah, at the N, okay, adjacent angles mean they share the same side. So this 61 degrees, its adjacent angle would be this huge angle created by the same, sharing the same side. Okay, so part B is saying that adjacent angles are supposed to be 61 degrees each. Well, like this first picture. But if we look at ours, that don't look right. I mean, yeah, this is 61, but this big guy, he's big. He's obtuse. Yeah. So part B is wrong because we don't know what this other angle is, but it surefire is not 61 like this. Yeah. So the part B is asking, does it look like this? And the answer is, heck no, it doesn't look like that. So that's not the correct answer. So adjacent angles, they do share a common side, but it doesn't say anything about they're the same degrees or that they are equal degrees on both sides. I did not write anything about that. So that word each is what makes part B wrong, because adjacent angles are not equal. This blue and this yellow are totally different. Okay, let's go to C. It says no because opposite interior angles. Well, I don't even know what those are. Let's go back and look. Opposite interior angles. Okay, it's like the inside of the Z. Okay, let's see. Oh, and it says the inside of the Z are congruent. Okay, let's see what ours said. No, because opposite angles are supplementary. I didn't write anything down here about supplementary. The only things that are supplementary are the things that say supplementary. Yeah, okay. So, no, because the opposite interior angles are supplementary. Okay, so here's that Z property that we've been looking at. And part C is saying that when we look at that Z, these two inside angles are supposed to be supplementary, add up to 180. But we said nothing about that on alternate interior, the definition. All we said is that they're congruent. So it doesn't say anything about adding up to 180. So we don't know if those add up to 180. I told you that it's not on this paper, so it might happen like once if both angles were 90 degrees, but overall, it's not going to happen. Okay, so C is out. Part D says yes, because alternate interior angles are 61. Okay, let's figure out what alternate interior angles are. Alternate interior angles are that exact same thing we just talked about, the Z. And we know that this bottom angle is 61 degrees, because that's what the picture gave me. Okay? Yeah. Now, if we can find out for sure that this top angle is also 61 degrees, then we can choose yes, because alternate angles are 61 degrees. So how can we figure out what this top angle is? Well, if we look at this OG picture, let's look at this 119. This 119, along with the angle right beside it, create, oh, what's this? A horizon. Yeah, this is that thing that I was talking about. As in, two angles right beside each other that have the same baseline, that fall on the same line. If they can create a horizon, then it should add up to 180 degrees. So, we know that this missing angle, this little missing yellow one, is something plus the 119 beside it to get me 180. Because both of those angles, since they make a horizon or straight line, they add up to 180 degrees. So let's see here. What plus 119 gives me 180? Or you can think of it as 180 minus 119. And that should be 61. And heck fire, that's that top left angle. Yeah, from the Z. So we know, so this top left angle is actually 61 degrees. Okay? What was D saying? D was saying, yes, they're parallel because their alternate interior angles are 61. And heck fire, yes, our alternate interior, those 61. Yeah, D. Woof. Okay, let's keep going. Part B says, are these suckers parallel lines? Why or why not? Okay, part A says, yes, because a triangle fits. No, we're not talking about things fitting. These are not a pair of shoes. This is math. Okay, we got to talk about numbers. We got to use our special words, but we're not going to use the word fit like we're trying to fit into a pair of pants. Okay, part B says, no, they're not parallel because adjacent angles are supplementary. Let's go look at our definition for adjacent angles. Adjacent angles. Blah, 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 blah. I don't see the word supplementary. And I don't see anything about 180 because supplementary is also 180. But anyway, it does not say that they add up to 180. Look at this picture. This picture of two adjacent angles, they sure don't add up to 180. So, okay, B is wrong because adjacent angles are supplementary. No, they're not. That's not in the definition, so don't choose that answer. Okay, now let's look. The next one says opposite interior angles are congruent. Okay, we're going to have to find where that is. Okay, opposite interior angles. That's... oh, this sucker. Opposite interior angles are congruent. Okay. Because opposite interior angles are congruent. So the words look good. The words look good. But over here on this alternate exterior, remember I told you that these two side-to-side lines have to be parallel? And on this corresponding, I told you those two side-to-side lines have to be parallel. I forgot to tell you here. On opposite interior, those two side-to-side lines have to be parallel. As in, if you have two parallel lines, their alternate interior angles are congruent. If you don't have parallel lines, they're not congruent. Congruent means equal. Okay, so let's check ours out. Let's look for our Z property, because remember, alternate interior angles means the Z property. So let me find my letter Z. Z. There it is, okay? And it looks like we already have this angle right here is 68 degrees. Okay, and this is saying the opposite interior angles are congruent, as in they're equal. And they are, but when we have alternate interior angles, the lines must be parallel. I think I spelled that wrong. So the question was, are the two lines parallel lines? Yeah, they are, because their alternate interior angles are equal. So C's out because it's supposed to say, yes, they are parallel because their opposite interior angles are congruent. So that's why C's out. Okay, let's look at D. D says, yes, because corresponding angles are 68. Okay, well, I know... okay, well, let's find what corresponding angles are. Corresponding are the F property or the two angles on the same side of the line, one from the interior, one from the exterior, one from the inside, one from the outside. Okay, let's see if I can draw my letter F. I might have to turn it upside down. Oh, there's my letter F. Okay, so this is my letter F. And that F property, or the corresponding angles, says that this sucker and this sucker are equal. They're on the same side of the line. One's interior. This guy at the very bottom left, that's an exterior. Okay, so now that I got it labeled, let's maybe put some numbers on it. Do we know any of these angles? We know 68. Okay, well, the question is this top left, top right 68? Because if it is, then we're going to choose it because it says, yes, they're parallel because those corresponding angles are 68. So let's see, how do we figure out this top angle? Well, if I look at this line that cuts the parallels, and I want to know what this top angle is, well, that's about to make a horizon, as in this 112 and this, whatever this angle P is, that has the arrow to it, whatever that is, plus 112 should add up to 180. Or we could think of it backwards. We could say 180 minus 112, and that does give you 68. So these two angles are 68. So since they're equal, that means they're corresponding angles. It's the F property. Yay, that's why these suckers are parallel. C could have been the answer if it would have said yes, because opposite interior angles are congruent. But it said no, they're not parallel. Alright, let's keep going. Next sucker. It says, are S and T parallel lines? Why or why not? Okay, well, let's see. Part A says that word fits. We're not trying to put on a pair of pants at Target. So we don't care about A. We need to use the words, vocabulary, or we need to use the numbers. We don't need to use a random general word. Okay, let's see. It says no because corresponding angles are 116 degrees each. Okay, well, let's remember what corresponding angles are. It's the F. Okay, it's the F property. Well, let's see here. Where is that F? Oh, I can kind of see it. Maybe right there. Yeah, okay. That makes an F. Okay, so let's see if they're 116 degrees each. Okay, so we know 64 degrees is up here. Well, okay, automatically we know B is out. Because these angles are 64 degrees. It's supposed to say 64 degrees, not 116. Okay, let's keep going. C says yes because adjacent angles are 64 degrees each. I think we've talked about this. Here are my adjacent angles. They share a common side, but they're worth different amounts of degrees. Like these, like for example, maybe 15 degrees and 30. Those share the same side, but they're not congruent. The numbers are different. So adjacent angles, it does not say anything about that word congruent, or that word equal. Equal. Yeah, okay, so since it didn't say that, that means that adjacent angles are not the same degree number each. That would only happen if I had maybe a 45 and a 45. But adjacent angles are not 64 each. Okay, so let's see here. Where's an adjacent angle? Okay. Let's check out this 64 degrees right here. Okay. He's 64 degrees. What's the angle beside him that shares that same side? Is it 64? Heck fire, no, it's not 64. It's obtuse. It's bigger than 90. It's definitely not 64 degrees. So part C said, yeah, they're parallel, because those adjacent angles are 64 each. Heck no, they're not. One's 64 and the other one is bigger than 64. So C's out because it says that word each. Okay, the last one says yes, because alternate interior angles are 64 each. Okay, let's see. Alternate interior is the Z. So let's check our Z. This Z is a little bass-ackwards. It's not quite, it's kind of flopped around. You see, it's like I kind of flopped my Z side to side. So it's like I turned it around. Oh gosh, see if I can do it. Oh gosh. Okay, yeah, it's like I turned that Z around. Okay, and the Z property says that the inside angles of that Z are supposed to be equal or congruent. Well, let's look at our picture. They told us that top angle is 64. They told us that bottom angle is 64. Heck fire, yeah, they are equal. They're 64 degrees each. So, yay, D.